Scientific revolution. It was a profound change in the European worldview in the late 16th and 17th centuries. The primary cause of the scientific revolution, basically, it was people start to think more reasonably, coming right out of the Renaissance with humanism. The most profound change in human history, you could argue that, because it's going to lead to the way we look at science, biology, astronomy, governments, the way people should be able to reason their life out. So you could argue that. It's a new intellectual climate, differed from the medieval and early modern worldview. This new climate, basically, we're going to go on reason rather than just the way things were in religion. So it's a rejection of authority. The best knowledge was practical, and it demystified the universe. Scientists of this era differed from their predecessors, combining mathematics and experimentation. So the roots of the scientific revolution, you could look at ancient Egypt, pyramids, mathematics. China, movable type. Remember, they had the movable type printing presses about 500 years before Gutenberg invented the metal type. Theirs was wood, though. Paper, and you can talk about the Chinese contribution to astronomy, but we can talk about that in the Middle Ages, in the Middle East as well, with the Babylonians, the Chaldeans, and those guys. Islam, you got medicine, medical advances, the ancient Greeks, astronomy and mathematics, and of course in medieval Europe you have alchemy, how metals have their properties, what kind of properties they have, herbologists, and of course cathedrals. So the one guy we're going to talk about here is Nicolaus Copernicus, and his dates were from 1473 to 1543. He's a Polish monk. He observed patterns of star and planet movement. He writes this book, and I know it's kind of hard to see there, but he writes this book on the revolutions of celestial spheres. He calls for a heliocentric universe. In other words, a sun-centered. It's not a geocentric or earth-centered universe. He calls into question the truth of scriptures, because the church had been preaching, or the church had been teaching, a geocentric model. In other words, the earth was the center of the universe and everything went around the earth. He says the sun is the center of the universe and the earth travels around it. So Copernicus, actually, he's kind of smart, because he waits to publish his book when he's near death, because he knew that publishing this book could cause him a lot of grief and basically a trial, inquisition, and he would probably be burned at the stake. So he chose to publish this thing right before he died. Galileo Galilei, what he does, he's an Italian scientist, and you see here it says he improved the telescope. He does not invent the telescope. I believe it's a gentleman from Denmark that invents the telescope. He just improves it so you can see farther into space. He made observations that basically prove Copernicus's theory of the universe. And he witnesses the moons, the planets, stars, sunspots. He observes, I believe it's Jupiter, for about 20-something years, 25 years, and he finds 4 moons that orbit around Jupiter. I think today there's like 21 we know of, maybe more. He wrote in vernacular, which means he wrote in the average language of the people, so the everyday person could understand what he was observing. So he was a great communicator when he wrote his book, because most people could pick up on what he was saying. He didn't use heavy jargon and scientific jargon, and he just broke it down to where people understood what he was saying. In 1633, He is brought up on an inquisition. His friend was actually the Pope, so he figured he could publish his book of 25 to 30 years of his work, and the Pope would be friendly to it because they were friends. However, the Pope brought him up on an inquisition and charged him with heresy, and they were going to burn him at the stake. He was forced to recant everything in the book and everything he had learned, and he does this publicly in church or publicly in the Inquisition. And he's placed under house arrest for the rest of his life, which was 9 years. But as he left the court, he was whispering and muttering under his breath, it turns, meaning the earth. This was a letter to the Grand Duchess Christina of Tuscany, this famous letter that Galileo writes. And to address the conflict between the Bible and the heliocentric theory, it argued that the Bible must be interpreted in light of scientific knowledge. He argued for a non-literal interpretation of the Bible. Galileo declared the Bible teaches how to go to heaven, not how the heavens go. The letter began really a lot of Galileo's trouble with the Catholic Church. So René Descartes, it's a French mathematician and philosopher. He's a transitional figure between the medieval Europe and the modern science of the day. He's a rationalist. He promotes deductive reasoning, predicting particular results from general principles. Remember, deductive reasoning is going from the general to a specific. So, as you see, he writes, he wished to develop a method where it could be used to yield scientific truth. He argued that abstract reasoning and math were more reliable path to truth. Our senses could deceive us, so we have to have some concrete proof. So he comes up with the saying, I think, therefore I am. So there's plenty of other scientists we could talk about. We're just kind of skipping through them. So I know we could talk about Bruno, who is an Italian scientist, and he also publishes a book, and he argues for a heliocentric universe, and he's right around Galileo's time. The church tricked him back into Italy, where they would try him in an inquisition and burn him at the stake for his views, and because he would not recant his statements and his findings. I think it took him 15 years to get him into Italy. But the last one we're going to talk about here is Isaac Newton. Isaac Newton discovers gravity. He's an English student, achieves fame at 24. He's an important mathematician and scientist. You know the story. He was in his 20s. He's sitting under an apple tree. The apple fell, and he wonders how that happened. And it sends him on this long quest of finding out what makes us stick on Earth and all that good stuff. So Newton writes this important book, and he lays out the scientific method. And along the way, he is one of the creators of calculus, the modern day study of calculus, which is the measurement of movement. So the significance of the scientific revolution, the contributions these scientists made, the universe comprehensible for the first time. People could start to understand it. The individual became much more important. Collective authority was not a source of wisdom. Individual intellect will be. And then after the revolution, God was viewed by many as either a remote master mechanic, or his existence began to be doubted completely. This begins a long adversarial relationship between science and religion that still continues today in some parts, and the revolution laid the foundation for the Enlightenment of the 18th century.